For years now, I've been wanting to make this exact video, taking a deep dive into the gut microbiome. But the more that I read and the more that I researched, I kept bumping into these words. It's complicated. Now, there are plenty of overly simplistic explanations online, together with fear-mongering and marketing trying to get you to buy all sorts of products.
It all starts in your gut.
To restore gut flora,
Contains live probiotics.
is it super resilient to survive the trip through your stomach?
Not all probiotic strains are the same.
Lactobacterium lactis, Lactobacillus H2CT, Lactobacillus casei.
Gives your tummy 20 billion friendly bacteria.
Contain 40 billion probiotics.
50 billion cultures with 60 billion probiotics.
With billions of probiotics.
Stick around and we'll uncover the truth and discover the surprisingly simple steps you can follow to have a healthy gut microbiome. So let's jump right in and travel to the other side of the world, to Cork, to interview Professor Jens Walter. He's written more than 180 peer-reviewed articles on the gut microbiome. What is the gut microbiome?
The microbiome refers to the microbial communities that colonize our gastrointestinal tract. They produce metabolic compounds, that are important for many aspects of our health and biology in general.
How many bacteria and things are we talking about here?
Well, I like to focus on the dominant community, and then it gets a little bit simpler, but we're still talking at least about 100 to 150 dominant bacterial species.
Right.
And then what adds to the complexity is then within these species you have different strains. You and I would probably have 50 to 60, perhaps even 70% of the species in common. Mm-hmm. When we then look at the strain level, as it goes even further down, we would have virtually nothing in common anymore.
What things affect how different they are?
It's our entire kind of life history. Are we vaginal born, or are we born through a C-section? Were we breastfed? Did we get antibiotics? What was in our formula? Just, with what piece of dirt did we put in our mouth? All of these. So it's a long history of, and then this is also why I think why even monozygotic twins, which end up with very different microbiomes.
What health issues have been associated with changes to your microbiome?
Many. There are hundreds of clinical studies at the moment that are looking at some aspect of the microbiome, probiotics. Pathologies for which we have very good evidence that the microbiome is involved would, for example, be certain infections. Clostridialis difficile infections, that is probably one of where we have the most really evidence that the microbiome is very, very important here. But then also a lot of chronic diseases, autoimmune diseases, pathologies, like obesity.
Is that associated with it rather than causative evidence?
We have a lot of very good research in animal models. So animal models of diseases, because we can keep animals without bacteria, or we can put specific bacteria into animals, and then you have complete causal information. And the research on animal models, for example, of immune-mediated diseases like colitis, also models of inflammatory bowel disease, or for example, models of immune-mediated diseases, multiple sclerosis, allergies. There we have very good evidence that in these animal models the microbiome is at least a very important contributor to the pathology. Yeah. So it's very good evidence and causal evidence in animal models. And then when it comes to humans, at least for most, we have better and less good associations.
Do you think we'll ever get to the stage where there's, like for a blood test, and this is how much iron you should have and it should be in this range? Would we ever get to the stage where that's the case for all the different gut bacteria, if we know these ones are not good, these ones are good, and this is the range you should be in?
I'm hopeful that we can at some stage get to this stage, and we have already at least some good ideas. I would say. So
how many years off do you think that is? Is that a long way? Like, are we talking 20 years?
For diseases where we are sure the microbiome plays a role, like C. diff, I would say we are quite close. Yeah? And then for others, it will be much, much harder. So 10, 20 years then, yeah.
And there's some companies that are already selling to the public at home kits, they're very expensive, where they can test their own microbiome and then they send them back results and recommendations. Is it too early for those sort of kits to be any use?
I would be very, very cautious at the current point. There's also concern amongst the scientific community that this entire space is not properly regulated at the moment, and there are now calls to action, in the literature that this should happen.
Do we even know which strains are good, not obviously for all of them because there's so many, but which ones are good and which ones are detrimental, or is it more like a balance, you just need some of them?
I think we have some good clues now. Again, we don't have the definite, causal experiment, but there are, bacterial species like Bifidobacterium, that's genus actually, so but species within the genus Bifidobacterium, Faecalibacterium, so we know, that they are anti-inflammatory. And then we have a few bacteria from which we are pretty sure, that they are detrimental. For example, there's a bacterium I'm getting very interested in called Bilophila vatsworthia. Bilophila stands for bile-loving, so it goes up with Western diet and saturated fat. And we know from animal models, if you put it into mice, you get inflammation and other pathologies. Yeah, so I think, and then a lot of the term is to some degree controversial, but often these dysbiosis, that you see in a lot of diseases, they often show this bloom of what we call pathobionts, like enterobacteria. So, where also a lot of, pathogenic bacteria are amongst this. So I think we have some good idea, that this is, something we don't really want. Yeah. So a lot of interest around a bacterium called Akkermansia, for example, also many of my colleagues. But here, this is an interesting one again, because there are, positive and negative studies, so as again, there it gets already complicated again. But I think, we're getting some clues. Yeah.
With the bacteria that aren't good or aren't so good for you, what is the mechanism like? Why are they bad for you?
I think there are a huge amount of complex mechanisms, but many of them actually cause inflammation.
Right.
Also this Bilophila, for example, causes inflammation, and again, we can test that. Then these pathobionts, like these enterobacteria, they not only cause inflammation, but they also thrive on inflammation, as it's one of them, one of the mechanisms by which they actually, establish a niche for themselves. Yeah, and then also they're metabolically active. So I think there is both actually for the good and the bad, is what they do. It's not so much just who they are, but also, the compounds they produce. They produce metabolites that are either beneficial to your immune system or detrimental. They produce metabolites that are, for example, carcinogenic, so they induce cancer. There's some good links between the gut microbiome and different cancers. And then they also then produce compounds, that are perhaps neuroprotective. Also we saw metabolites, increasing on a very healthy diet, which we know definitely they come from the gut microbiome, but there's good evidence that they protect your nerve cells and are anti-inflammatory and are probably even antioxidants. So it's both the bacteria themselves and how they invade and or try to encroach to the immune cells, and then it's the compounds they produce.
The mucosal layer as well, is that affected with the microbiome or no?
So I am really interested in the mucosal interface. So in our gastrointestinal tract, the epithelium is covered by a layer of mucus. That's a little bit more patchy in the small intestine, but it's quite thick in the large intestine. And this is it's an important protective mechanism. So our body likes to have a microbiome because of the benefits, but our body also likes to keep the microbiome at a safe distance. And this mucus layer is one important mechanism now. Interesting is now that bacteria also utilize mucus. They eat it quasi. Right. And they eat even more of this mucus if we don't feed our bacteria. So if you starve your microbiome because you would just eat a diet of refined foods without dietary fiber, that these bacteria then start to eat the mucus layer. They degrade it. The mucus layer becomes thinner. And because of this barrier doesn't work as well, and you get inflammation. And this is incredibly well. I think there are probably 12 or 14 leading groups working on the microbiome that have shown, that in mice, when you degrade the mucus layer, by a essentially, fiber-free modern diet, then you actually have all kind of problems.
And when you say inflammation and that sort of thing, are we talking through the whole body or in the gut?
The initial effect is intestinal inflammation, and there's a lot of interest around this in a lot of different contexts. But then we also do think that the microbiome, makes a contribution to this systemic, more, subclinical metabolic inflammation that we see, in a lot of these chronic pathologies.
As a modern society, we tend to like to take a tablet to fix everything. We don't want to change our behaviour. So probiotics are the obvious question. We'll get back to the interview in just 1 second. But first, travelling to do this is heaps of fun, but it's also really expensive. And if you put all of those expenses on a normal bank card, you not only get a bad exchange rate, but you also get an overseas transaction fee added to each of those purchases. As well as that, on the last 3 international trips we've done, the bank has blocked our card for the first few days, even though we've told them that we're going to be travelling. So for that reason, on this trip, we're using today's sponsor, Revolut. In the app, you can exchange your money into 30 different currencies at a competitive exchange rate. And then you can pay in the local currency, so there are no extra fees on all your purchases. With the Revolut Metal plan, you also get a fancy customisable stainless steel card and other great perks like a masterclass subscription or discounted access into the airport lounges, which is so useful on these long haul trips. If you download Revolut using my link and use it for one purchase, and Revolut will give you $40. Now let's get back to the interview. Probiotics are the obvious question. So leading on from that, if you took a lot of probiotics but didn't take any fibre, 1, are you going to be starving them and they're not going to stick around, or 2, are they going to be eating the mucosal layer?
Most probiotics will not degrade your mucus layer. And the reason for why I think this is because most probiotics don't really colonize.
Right.
They are not really successful in I've mentioned this is an ecosystem, this is competitive, there are hundreds of species that are already there, they have their niche, their place, and when the probiotic comes in, and specifically the probiotics that are in commercial products, so first, most of them aren't even real gut organisms.
Right.
And so they come into the gut, they don't really do much in terms of colonization or perhaps a bit more metabolism, but definitely no colonization, and then they're just washed out, so, and that, depending on the probiotic, happens within 3, 4, 5 days, or some, stick a bit longer. And then if in very rare cases, I actually worked on this, if you really take the right probiotic, then you can actually, implant it for some time. But most probiotic products that you grab from a shelf, that's not the case.
So it's just like a traveller passing through, it's not living there. And so when you say the right ones, or if someone's going, well, I've just had antibiotics and I've destroyed my microbiome, are there right ones that they should be looking for on the shelf?
So I've actually tried to, because I get this question all the time, specifically with the antibiotics. Yes. I struggle to find a probiotic that is advertised as for taking after antibiotics. That I liked,
Right.
So, but I'm not. That doesn't mean that it doesn't exist, So because there are a lot of products out there. But if I say the right ones, it's just that, and this is it's starting now. But I just mentioned that most probiotics are composed of species that are not dominant members in the gut microbiome. But these products are coming now, and there are more and more probiotic products that use, for example, species of bifidobacteria, which I already mentioned, and they are real members. And actually the project that I mentioned, where we saw a probiotic persisting for half a year, that was a species of bifidobacteria, Bifidobacterium longum. So
Right.
this would be amongst your top 50, in the gut. So if you give this, then you can actually see stable colonization for around half a year.
With the study that you did, how long, did they take it once? Did they take it every day?
They took it for 2 weeks.
Okay.
Yeah, but I have to. We've never, and I don't think anyone has systematically studied, how long you would actually have to take it for it to colonize. Yeah, but in this study, I think it was 2 weeks. Yeah.
So certainly all the advertising is you need to be taking this every day and forever. You wouldn't recommend that?
I know, because I said most probiotics don't colonize. Yeah. So then you actually, if we assume that these probiotics don't colonize, which again, that's the 99.8 or so percent of the studies really don't show colonization. So if that's the case, but if we assume that they are still metabolically active and they produce something that is of value, then you would probably benefit from taking them every day. So the advertising is not wrong here. The question is just then, do they actually do something?
Yeah, I've read a lot of studies about using, particularly with C. diff, using fecal transfer. That's obviously more a medical type of thing. Is that something you think we'll see more of in the future for specific conditions, if the microbiome's involved in conditions or shown to be more involved?
Oh, definitely. Yeah. So also this FMT, fecal microbiota transplant, is now pretty much a clinical standard in many countries for treatment of C. diff infections that that are not responding anymore to antibiotics. And the cure rate is 85%, 95%, depending on which study you look at. So very, very successful, makes all the sense in the world. So there are now, I think, more than 400 clinical trials at the moment on this clinicaltrials.gov database that uses FMT in a whole range of conditions. C. diff is still the only one for which we have consensus that it really works. And there is at least promising data in other conditions, but it will definitely come. The question is now, so it will probably be successful for some things, and it will probably just not work for others.
What things damage the microbiome in terms of making it less healthy?
So there is a lot of factors that basically disrupt the microbiome, either by preventing us from getting bacteria like C-sections, or by killing bacteria like antibiotics, or by us not feeding them well. That is both formula and modern foods, or by compounds in modern foods that then again disrupt microbiome. It's also important to consider that it's not necessarily only who is there, but it's also what they're doing. So I'm getting much more interested in this, that perhaps you and I, it might not be that you or I have an unhealthy microbiome, but or you might have a super healthy microbiome, but if you don't feed it, and if you eat a diet full of processed junk food, then no matter what your microbiome looks like, it is going to be doing things that are probably detrimental to your health.
Emulsifiers, artificial sweeteners, all of those things having a negative effect. How are they negatively affecting it?
So there's quite a bit of research on emulsifiers, which we mentioned this mucus layer, which is protective. So emulsifier is one of the factors that the scientists are now discussing to disrupt this mucus layer. So it's not only the starvation of the microbes and the microbes degrading it, but there's good evidence that these emulsifiers actually somehow damage the mucus layer. It's just a recent study actually showing that emulsifiers in the diet probably contribute to inflammatory bowel disease. Also again, we even are now moving towards clinical kind of findings that support they have a negative role. I find the research on artificial sweeteners less convincing. At least it's not yet at the stage, I think, to make some definite conclusions, I would say.
So many products at the store have emulsifiers in. So that's going to be hard if they have to change that in manufacturing.
Yes, and that's one. It's one of the many reasons why we in the group have become very interested in essentially non-industrialized type diets. Yeah.
And you've done one of the very rare at this stage clinical trials with the diet and microbiome. Can you explain how that study was set up?
My group went to rural Papua New Guinea. These microbiomes look very different. They're much more diverse. There's many species that we have lost. What we thought in our human trial is let's design a diet that resembles, a non-industrialized diet. Also how human populations, that are not yet affected by, mechanized, a food system essentially. What diet would they actually consume. They don't eat that much meat, so it's very plant rich. A lot of leafy vegetables, pulses, beans, sweet potato, vegetable, probably fruits. A lot of these diets are very, very high in dietary fiber, and actually higher than what is even recommended in modern society. So we went to actually almost 45 grams on average of dietary fiber. And then there was a little bit of animal protein, in the form of chicken or salmon or pork, and no beef, because Papua New Guineans don't eat beef. Not saying that this should be the recommendation, but that was our model, and no dairy and no wheat.
Does that have an effect, or that's just because that's what the PNG diet was? Does that have an effect on the microbiome that you know of?
I don't think there is anything inherently bad with wheat.
With the wheat, it's just not in there.
Dairy, again, the same thing. We left it out because it was the experimental design. I do think there is a lot of components of specifically high-fat dairy that has very negative effects on the microbiome, and this is very well established. Actually, this Bilophila that I mentioned, this is a bacterium that we know that blooms with milk fat, saturated animal fat. Again, I wouldn't recommend to go completely off dairy, but I would definitely focus it on lower fat varieties and perhaps fermented varieties like yogurt, for example.
You've got no wheat. Are there any other whole grains in there?
There are whole grains, things like millet. Then I think we use quinoa. There might be some sorghum in there. Anissa Ahmed, she spent, I think, more than a year in a kitchen and cooked then non-industrialized type foods for the participants of the study.
So this diet is called the NIMI diet, the non-industrialized microbiome restored diet. We will be providing all of the meals and snacks that you'll be eating for 3 weeks.
And what was the result? What was the effect on the microbiome and overall health?
Profound and surprising, and much more than we actually anticipated. Let me start with weight, because people actually lost weight. And this is something we didn't expect at all. You can actually eat way more, and it also supports kind of a lot of dietary recommendations who say, look, you eat fruit and especially vegetable as much as you like, and that really seems to be true. Yeah. So then we looked into the blood, and there we saw very interesting changes. So we saw a metabolite called indole-3-propionic acid, and that went up. And there's a lot of interest in this metabolite. So it's neuroprotective, it's an antioxidant, it's linked to, it's probably anti-inflammatory. There's the literature exploding around this. So I think this is a metabolite that makes me really excited, that you can, essentially, and that is perhaps, why plant-based diets, for example, are linked to longevity, and the prevention of, neurodegenerative diseases. That's no speculation, but it would provide one explanation. Yeah. Then carcinogenic metabolites went down. Also a marker of cancer, and also secondary bile acids, which we know cause colon cancer, they went down. Yeah. Then we looked into these indicators of chronic disease. So cholesterol went down 17%. So healthy individuals, 3 weeks, so the bad LDL cholesterol went down 17%. Blood glucose went down 6%. And all of this was highly statistically significant, despite the fact that it's a small study. Yeah? So also very low p-values. CRP, which is a mark of inflammation, went down 14%. And calprotectin, which is a mark of intestinal inflammation, went down 21%. So absolutely profound change. I think it's fair to say that, especially if you look at the blood metabolites and at the clinical markers, I would say there you would I think there would be very few scientists who looked at this and would not say, look, these subjects are substantially healthier.
And that was only in 3 weeks. And then when they did the washout and went back to their normal diet, how long did it take for that benefit and those better levels to drop back to normal?
The averages all went kind of back to normal after 3 weeks. Yeah.
So they need to sustain the plant-based diet. It's not just do it for 3 weeks and you'll be healthier.
I think if you want to get benefits from diet, you just have to eat healthy in life. I think it's better to eat healthy for most of the year and cheat initially, or cheat occasionally. Yeah. Than the other way around, where you just eat a bad diet and then think, just an occasional healthy meal will do it. So that's probably not working.
So essentially, when we are choosing what we eat. We're not just feeding our bodies, we're feeding all of the gut microbiome. And if we feed them the right things, we end up with a healthy microbiome. And if we feed them bad food and junk food, you get the microbiome you deserve.
From everything we see, it's probably, the composition is probably not even different, not much change, but functionally, it's very different. So probably the sentence should be, your microbiome does what you deserve.
Right, so it behaves differently.
Or behaves is a good word. Yeah, it behaves. I think from everything we see, it's which again probably makes sense. Because it's not that we have our individual microbiome. We discussed that's probably based on the 30-40 year history of our life. So that's actually not really changing. But then the relative proportions change of these. And definitely what they do, and that, are they degrading the mucus layer? Are they producing metabolites that are either beneficial or detrimental? That's hugely influenced by your diet.
In nutrition, knowledge doesn't always equal behavior. So knowing everything that you know, is your diet very high in vegetables and very low in processed food? And are you essentially following the sort of the NEMI diet that you studied?
So I'm trying. Yeah, and I would say I'm doing an okay job. Yeah, it's probably not as good as it should be, but I am trying to follow it. I also probably almost prefer that kind of diet now, as I'm not as you can really train also your body, to not crave, junk food as much, which was harder in the past. Yeah, so yeah, I would say overall I'm doing an okay job, but then I also I definitely struggle actually with tasty foods that I don't think are that healthy, like cheese and salami. One really important message I would like to bring across is the magnitude of the findings. Not only ours, but also others. I think everybody kind of knows, you should eat healthy, but because it does a little bit, it's not a little bit. It's just absolutely life transforming. As we and others, if you think about, we have drug-like cholesterol effects. We have drug-like effects on blood sugar. And then if you look into the field, on, for example, how food influences, life expectancy, there are studies now showing it's essentially 10 years. When you get 10 years, not also longer life, but also healthier lives, because you're preventing these chronic diseases, which make your life much, much harder in the end.
All the recipes for the NEMI diet have been written out for you here, and you can download it for free. Give it a go and see how much extra fibre and vegetables you can get into your day. A huge thanks to Jens and his family for having us and being so hospitable. And thanks to you, my subscribers. And a special shout out to my patrons. Thank you for all of your support. Make it a great week by being kind to others, and I'll see you on Friday.